Ma'am, you can start, ma'am.
Today only 4 students. Prasanna, today only 4 students.
They're entering, ma'am. You can start, ma'am. In YouTube, people have already joined.
Oh,
Your voice is little less, ma'am, actually.
okay.
Now it is audible.
Okay, fine. Yesterday I have given you homework, a few problems from complex numbers. If you have any doubts regarding those, you can ask, you can type in the chat box quickly so that we can complete complex numbers, and today we can go to quadratic equations. So no doubts. Let us start quadratic equations then. First, I'll give you a few important points, synopsis. Later on, we can go to the questions. Because there is a lot of to do today, we have to hurry. Here is the first set of questions from the lesson, quadratic equations. Quickly, we will go through some points. The first one, you can take ABC complex numbers. But remember, A should not be 0. Then you can call AX square plus BX plus C as quadratic expression, not equation, just expression. But suppose if you take AX square plus BX plus C equal to 0, then that will become quadratic equation. So that is the difference between quadratic expression and quadratic equation. Every quadratic equation has root, solution, or answer. Suppose if that answer or root or solution is alpha, that means this alpha you can put it in place of x in the equation. Put x as alpha, put x as alpha. Then you will have A alpha square plus B alpha plus C. And definitely the answer will be 0. So every root, every solution can be put into the equation. You can substitute for x and definitely you will get the answer 0. How to find the roots? How to find the solutions of the quadratic equation ax square plus bx plus c equal to 0? There is a formula called quadratic formula. This is the quadratic formula. Minus b plus or minus square root of b square minus 4ac by 2a. Now, if a quadratic equation ax square plus bx plus c equal to 0 has two roots, two answers, alpha and beta, then when you add up the answers alpha and beta, alpha plus beta, the sum of the roots will be equal to minus b by a. And when you multiply the roots, the product of the roots, alpha, beta, will be equal to c by a. All these formulas are very important. You have to memorize them. So similarly, if alpha, beta are the roots of ax squared plus bx plus c equal to 0, then this equation can be factorized. Ax squared plus bx plus c, you can factorize and write it as first a outside, x minus alpha into x minus beta. X minus alpha, x minus beta. Alpha, beta are the roots in the x minus alpha and x minus beta. Similarly, if the quadratic equation has roots alpha, beta, x minus alpha into x minus beta will be 0. And when you expand it, x squared term, x term if you take, it will have minus of alpha plus beta, and the constant term is alpha beta equal to 0. How? See, x minus alpha into x minus beta equal to 0. I'm multiplying. X square minus beta x minus alpha x plus alpha beta equal to 0. X square, take minus common and x common from these two terms. Left is alpha plus beta, and then alpha beta equal to 0. This is how we get. So what you can understand from this is, if I give you two roots, alpha as 2 and beta as 3, you can make the quadratic equation. How? X square minus sum of the roots. Add up 2 and 3. 2 plus 3, sum of the roots into x plus product of the roots. Multiply 2 and 3 equal to 0. So x square minus 5x plus 6 equal to 0 is the quadratic equation. If you are given roots, you can find quadratic equation. If you are given quadratic equation, you can find the roots. Okay. Next one. If a function is given as ax squared plus bx plus c equal to 0, a quadratic equation. This is a quadratic equation. Now, if you want to make another quadratic equation whose roots are reciprocal of the roots of f of x equal to 0. That means, suppose for this quadratic equation, the roots are alpha, beta. For another quadratic equation, the roots are reciprocal, 1 by alpha, 1 by beta. And then the quadratic equation you will get by f of 1 by x equal to 0. Actually, how to use this formula, I will tell you. Suppose we will take this equation only. I will erase this so that we will have space. Suppose there is a quadratic equation x square minus 5x plus 6 equal to 0. Its roots are 2 and 3. Now I want to make another quadratic equation whose roots are 1 by 2 reciprocal and 1 by 3. How will I get that quadratic equation? In place of x, write 1 by x square minus 5 into In place of x, write 1 by x and plus 6 equal to 0. This is the new quadratic equation. So you have to take f of x only, but in place of x, you have to put f of 1 by x. You will get the new quadratic equation. So what that will be 1 by x square minus 5 by x plus 6 equal to 0. Denominator is x square. So 1 minus 5x plus 6x square equal to 0. Or the last step, 6x square minus 5x plus 1 equal to 0. For this equation, the roots will be 1 by 2 and 1 by 3. So this is how you have to use all these, the next few formulas. Suppose f of x equal to ax square plus bx plus c equal to 0 has roots alpha and beta. You have to make another quadratic equation whose roots are greater by k. That means now the roots are alpha plus k and beta plus k extra. Then how will you get that new quadratic equation? In the same function, replace x by x minus k. You will get new equation. Now I'm not giving example for each and every one. One I have shown. Okay, the next one, next formula. If ax squared plus bx plus c equal to 0, the quadratic equation, or f of x, has roots alpha, beta. And now you have to form a new quadratic equation whose roots are smaller by k. So the new quadratic equation roots will be k lesser than alpha, k lesser than beta, smaller. Then how will you get the new quadratic equation? The same function you have to take, but x you have to replace by x plus k. The concept is same. Okay. Next. Again, if f of x equal to ax square plus bx plus c equal to 0 is a quadratic equation, you have to make a new quadratic equation whose roots are numerically but opposite in sign of the roots of f of x equal to 0. How will you get the new quadratic equation? F of minus x. X has to be substituted by minus x. So based on this formula, I'll give you one question here. Suppose x square minus 5x plus 6 equal to 0 is the quadratic equation I'm giving you. The roots are 2 and 3. Now I will give you the roots as, I'll take another color. I'll give you the roots as equal but opposite in sign, minus 2 and minus 3. Instead of 2, 3, equal but opposite in sign, minus 2, minus 3 I will give. Then how will I get the new quadratic equation? This x has to be replaced by minus x. So minus x whole square. Minus 5 into x is minus x. Plus 6 here, nothing to substitute. Equal to 0. Or x square plus 5x plus 6 equal to 0. So this is how you will be writing or using these formulas. Next. If ax square plus bx plus c equal to 0 is a quadratic equation, you have to form a new quadratic equation whose roots are multiplied by k. Then you will get the new quadratic equation by substituting x by k. And the next formula is, there is a quadratic equation ax square plus bx plus c equal to 0. For this quadratic equation, b square minus 4ac is called discriminant. Just b square minus 4ac is called discriminant. I'll put the next set of questions, formulas. After 13th. Here is the next set. In the quadratic equation ax square plus bx plus c equal to 0, depending on b square minus 4ac, we can tell about the roots. If b square minus 4ac is a negative number, then the roots will be imaginary. Conjugate complex numbers. Conjugate means what? If one root is 2 plus 3i, the other conjugate will be 2 minus 3i. These will be the roots. If b square minus 4ac is 0, the roots will be real and equal. That means both the roots will be like this, 7, 7. Same roots, equal roots. If b square minus 4ac is greater than 0, the roots are real but not equal. So the roots will be like minus root 3 or 5, something like this. Real but not equal. They will be different. So this is in broad when we are taking ABC as real numbers. For 15th one, still this is more explained clearly. Like if b square minus 4ac is lesser than 0, same thing, roots are imaginary, conjugate complex numbers. If b square minus 4ac is 0, roots are rational and equal. Why now they are not saying real? Because A, B, C are rational, not real. I mean, of course they are real, but in that irrational numbers are not included. So A, B, C are rational. That's why the roots are rational. Then if b square minus 4ac is greater than 0, there are two cases. B square minus 4ac is a perfect square. B square minus 4ac is not a perfect square. If it's a perfect square, the roots will be rational and not equal. If b square minus 4ac is not a perfect square, then the roots will be irrational and not equal. So further they are explaining that. Okay, there are two quadratic equations, a1x square plus b1x plus c1 equal to 0, a2x square plus b2x plus c2 equal to 0. If both of them have a common root, same root, like this equation will have 2 and 3 as roots, this equation will have 3 and 7. So 3 is the common root in both the equations. If such a thing happens, then you can say C1A2 minus C2A1 whole square will be equal to A1B2 minus A2B1 into B1C2 minus B2C. And that common root 3, how will you get the common root? By taking C1A2 minus C2A1 by A1B2 minus A2. Next, if the quadratic equation's roots are imaginary, that is complex roots, then ax square plus bx plus c and a will be having same sign. But if quadratic equations roots are real and equal to minus b by 2a, if the roots are real and equal to minus b by 2a, then ax square plus bx plus c and a will have same sign. So till here, these formulas you must be very well aware of. After that, there are some more shortcut formulas. As I told you, there is no explanation for the shortcut formulas. So I'm just giving you the shortcut formulas you can learn. You cannot ask like why this is happening. And that's why I'm not reading it. I'm not explaining much. If you can memorize, you memorize. Otherwise, you have to do in the long way. These are the shortcut formulas. From here, shortcut formulas start from 28th. I'm drawing a line. Forty-one is not yet complete. So all these from 28th. Of all, this 46th one is very interesting. I have seen this kind of question many times, this formula. Suppose you are given square root of x plus square root of x plus square root of x plus like this infinite times. The answer will be 1 plus square root of 4x plus 1 by 2. Like that, you can use this formula for any other, instead of x, if you have any other number, then also you can use. So these are the formulas of quadratic equations, which you have to learn, shortcut formulas and long. Okay. Again, I am asking if you have any doubts from the homework, which I gave you yesterday, from complex numbers, you can type in chat. I will do those questions. If not, we will go with quadratic equations questions. Hello, Suresh. తర్వాత మాట్లాడతా. So still I did not get any response. So we will start questions from quadratic equations. Again, a few I will give you as homework. We'll do as many as possible now. Remaining, we will take it as homework. Here are the questions. Those who can do it, they can start doing. They need not wait for me. Later on, when I do it, you can see my answers. So the first question is, we have to make it as a quadratic equation and then solve it. Otherwise, directly you can substitute and see also. Like if you put 2 into the equation, 2 plus 1 by 2, you will not get 2. That means this is not the answer. Similarly, from B, you can put -1 and C in the equation which they gave. X is -1 plus 1 by x is -1. When you are adding up, you are not getting 2. So B is also not the answer. So C also will not be the answer. That means none of these. D will be the correct answer. Next, question number 2. The roots of the given equation. A quadratic equation is given to you. Which are the roots? That you have to see. So actually 1 is common in all the options. So you can't check 1. Instead of that, you can check other things. You can put other things and check. Or you can do in the long way also. What is the long way? Here A is, the long method is A is P minus Q, B is Q minus R, C is R minus P. Then X will be minus B plus or minus square root of B square minus 4 into A into C by 2A. You have to solve this and see what answer you will get. So how you are going to simplify this? First of all, I will write the outside one as R minus Q. And inside, I will expand it. Because I have to take the square root, I have to expand. So when I expand, I will have Q square minus 2QR plus R square. Then I will multiply. So PR is multiplied by -4. Minus P square is multiplied by -4. Minus QR is multiplied by -4. PQ is multiplied by -4. This is what I have. Denominator, I will keep same. Of course, this long method is difficult. So now, what all will cancel or what all can be simplified, that you have to do it. So how will you do? R minus Q plus or minus Q square is single, R square is single, 4P square is single, but minus 2QR and 4QR will become 2QR. And then minus 4PR is single, minus 4PQ is single. Obviously, when there is square root, we must have square. So that square root and square will cancel. So inside the square root, I need square. What that square will be? Wherever, suppose if it is Q square is there. So Q is having a positive one. Q is having positive. So I can take just Q. If you want, you can take negative Q, but I am taking positive Q. And then R square. R is also positive here. So I will take positive R. But for this 4P square, I will take negative 2P because there are some negative terms also. Wherever P is there, the term is negative. So for P, I have taken like this. By 2 into P minus Q. So this will be R minus Q plus or minus Q plus R minus 2P by 2 into P minus Q. If I take plus here, then R minus Q plus R minus 2P by 2 into P minus Q. Q will cancel. R will cancel. After that, 2 will cancel. I have minus P by P minus Q. Minus P by P minus Q. That is present in C. It is present in C. Minus P. Completely it is not present, but a little of it is present. So that I can take. I think I made a mistake here. My pen wasn't writing. So R minus Q plus R. I wrote plus, but it came as minus. Minus 2P by 2 into P minus Q. Only Q is cancelling. So 2R minus 2P by 2 into P minus Q. 2 also will cancel. R minus P by P minus Q. Option C is there. So option C will be the correct one. There are many ways to find this answer. I will tell you one more method, shortcut method only. This I told you so that you will know the long method also. What is another shortcut method? Let me tell you. If the two roots are given, we will find product of the roots. R minus P by P minus Q, product of the roots will be C by A. What is C in the equation? C is R minus P by A is P minus Q. So both the sides we are getting same answer. That means answer C is correct. You can check the product of the roots and you must get C by A. That way also it can be done. Next is question number 3. Question number 3 is looking little bit different. Why? X square plus y square, you got something new, y square. And xy equal to 12 is given. You have to find x. What is the value of x? That's the question. So what to do? Actually, I must not have y. I must have only x square. So x square plus y square is given as, see, square is not writing. My pen is not writing. X square plus y square is 25. Xy is 12. I don't want y square. So y I will take as 12 by x and I put it here. X square plus y is 12 by x whole square equal to 25. This is how I will remove the y. Now I will make a quadratic equation kind of thing. X square plus 144 by x square equal to 25. Or x power 4 plus 144 equal to 25x square. Or x power 4 minus 25x square plus 144 equal to 0. This is how I made a quadratic equation. Actually, this is not looking like quadratic equation. You may think it is a quartic equation. But if you want, you can make it as a quadratic equation very easily. What to do? Put x square as y. That means x power 4 will be y square. So write y square minus 25 x square as y plus 144 equal to 0. Now you can factorize. Very easily it can be factorized. What are the factors? 16 and 9. Y minus 16, y minus 9. That means we got y is 16, y is 9. But y we have taken for x square. X square is 16, x square is 9. That means what are we getting for x? Plus or minus 4, plus or minus 3, which is present in option C. This is how we take. Now, if you want easy way, then what we have to do, shortcut method, take this equation, the equation which I have highlighted, this equation, put the options and see. Like, put x equal to 3. What will you have when you put x as 3 in this? 3 square is 9 plus 12 by 3 is 4. 4 square is 16. You are getting 25. But 3 is present in A, B. So you have doubt again. So check which one is not present in any of these. Present in only one. Present only at one place. And that is minus 4. Minus 4 is not present in any of the options. Minus 4 is present only in C. So you check with minus 4. That would be the best thing. So how to check? Minus 4. Put x as minus 4. Whole square, 16. Put x as minus 4. 12 by minus 4 is minus 3. When you square minus 3, you will have 9. You are getting 25. So for minus 4, you are getting the correct answer. For 3, you are getting the correct answer. That means option C will be the correct. Like this is the shortcut method. For each problem, if you think there will be a long method, there will be shortcut method. If you are good at the concepts, you can yourself find out one shortcut formula. So for that, concepts are necessary. Fourth question. The roots of this equation, they're asking. So first of all, make it as a quadratic equation. Ax square is x square term minus a square plus 1 into x is x term. Then here a into 1, a is a constant term. This became a quadratic equation. Now, the roots are given to you. Product of the roots. Take any option, first option, second option, third option, any option. Product of the roots you have to see. Suppose if you take option A, product of the roots a into 1 by a. It must be equal to c by a. What is c? This is c, this is a. In the equation, this is c and this is a. So product of the roots is c by a. In both the cases, we are getting the same answer. And that's why option A can be taken as the correct answer. The next one is question number 5. Question number 5, due to the typing mistake, it did not come properly, but I will write it. What is question number 5? You can see. 2 plus 1 by 2 plus 1 by 2 plus 1 by 2 plus, like that it will continue up to infinity. What is the value of this? This is what you have to find. So what I will do is, I will take this entire thing as x. This continuing thing, I will take it as x. That means 2 plus, starting from 2 plus onwards. But what I will write is 2 plus 1 by, this starting 2 plus, I will take it as x. This is also in 1 by x only. So I will write it as x. I'll make a quadratic equation. X equal to 2x plus 1 by x. Or x square equal to 2x plus 1. X square minus 2x minus 1 equal to 0. In this way, I got a quadratic equation. This quadratic equation, I can solve it. How will I solve this quadratic equation? X equal to minus b plus or minus square root of b square minus 4ac minus 4 into 1 into minus 1. So it becomes plus by 2a. So 2 plus or minus square root of 8 by 2. Square root of 8 is 2 root 2 by 2. This 2 and 2 and 2 will cancel. 1 plus or minus square root of 2. That is the final answer for the value of x. X we have taken as the question. And again, there is a printing mistake in the answer, but option, we can take C, option C. 1 plus or minus square root of 2. The square root of 2 is missing. But if you observe carefully, 1 plus square root of 2 will give you a positive answer. 1 minus square root of 2 will give you a negative answer. But if you see the question, look at the question which I have rewritten here. There is no scope of getting negative answer because you don't have even 1 minus here anywhere. Everywhere plus, plus, plus. That means 1 minus square root of 2 will not be the answer. So I can't take this, I can't take this. But 1 plus square root of 2 is in B. So I have to go for B. So after getting the answer also, you have to analyze it. It's not that easy to write the answer directly. Okay, let's go to the next question. I will put 6 and 7. As I told you, you can start doing if you know it. The number of real solutions of the given quadratic equation. So this quadratic equation, I have to factorize. It is factorizable. How will I factorize? I will keep mod of x like that only. I will write mod of x minus 1 is the first factor. Mod of x minus 2 is the second factor equal to 0. That means mod of x will be 1. Mod of x will be 2. If mod of x is 1, then what will happen? X can be plus or minus 1. And if mod of x is 2, what will happen? X can be plus or minus 2. That means 4 answers you are getting. 4 solutions you are getting. So option D will be the correct answer. Next, coming to question number 7. I told you, it's like a quadratic equation only. Don't get scared on seeing x power 4. If x power 4 is there, when you factorize, you will have x square like this. So how will you write the factors? Minus 9 and plus 1 you get. Equal to 0. So x square will be 9. X square will be minus 1. X will be plus or minus 3. And here x will be plus or minus I. So plus or minus 3, plus or minus I. It is present in option B. That means we have to choose option B. Let me copy the next set of questions. Here. In this question, question number 8, 1 root of the quadratic equation is given as 3 plus root 5. Obviously, they're asking the other root. It will be the conjugate, 3 minus root 5. Option A will be the correct answer. So remember this. If one root is irrational, then the other root also will be irrational and it will be the conjugate. Okay. So some are tricky questions like this. Next is the roots of this equation. Actually, The equation is not in the proper form. There is a printing error. And that printing error, I will tell you what it is. It is square root of 3x plus 1 equal to x. This is the equation. You have to find the roots. You can put the answers and check. Instead of going in a long way, put the answers and check. For example, 0 you will put and see. If you put 0 for x, you will have 1 plus 1 equal to 0, which is wrong. So 0 is not the answer. That means C also will be wrong. Next, you put 1 and C. If you put 1, what will you have for x? Square root of 4 is 2 plus 1. You're getting x as 1 because you're putting x as 1. 2 plus 1 is not 1. So B is also wrong. That means only one option is left. That is D. None of these options are correct. Let's go to the question number 10. Again, this question number 10, there is printing mistake, and that is x equal to square root of 2 plus square root of 2 plus square root of 2 plus square root of 2 plus, like this, it will go up to infinity. You have to find the value of x. So what I will do is the first square root of 2 plus I will write, but the remaining square root of 2 plus 2 plus 2 plus, these are nothing but x only. Like this I will make it. Now in this you can substitute the options and see. Obviously, because the square root is in front of square root, there is positive sign. It is plus. So it can't be -1. You can cut the A option because square root should be a positive answer. Okay, now we will see whether B is being correct or not. B means it is 1. So put x as 1. 1 equal to square root of 3. This is wrong. B is wrong. Put C. X as 2. 2 equal to square root of 4. Yes, this is correct. So option C is the correct answer. Okay, next. Question number 11. P of x is a quadratic expression. Q of x is another quadratic expression. AC is not 0. P of x into Q of x is 0. This is another equation which will have at least how many roots it will have. That is what it is asking. So, what to do? What the roots will be? The roots can be, all the 4 roots can be. Why am I talking about 4 roots, first of all? Because P of x is quadratic. Degree is 2. Q of x is also quadratic. Degree is 2. When you multiply degree 2 and degree 2, the degree will become 4. So when the degree is becoming 4, you may have 4 roots. It's not necessary that you must have, you may have. So you may have 4 real roots, you may have 2 real roots, you may have 4 imaginary roots, or none of these. So we have to start. How to start? We will start with assumption. Let us take all the 4 roots are imaginary. I will erase this top one. I will think there are 4 roots. What are they? Alpha, beta, gamma, delta. Let us take all the 4 roots are imaginary roots. 4 roots are imaginary roots means what? For the first equation, for this equation, it must have imaginary roots. For this equation also, it must have imaginary roots. For both. Imaginary roots means what? In the first equation, the discriminant should be negative. In the second equation, what is the discriminant? B square minus 4AC should be negative. So sorry, it got muted. So both the discriminants must be equal to or lesser than 0. Suppose if you add them, if you add these two, b square plus d square, because minus 4ac and plus 4ac will cancel, it must be negative. But how b square plus d square will be negative? Because square is positive, square is positive. Two positives can never give you negative. So what we thought is wrong. 4 imaginary roots are not possible. I can cancel option C. Now I have to go for another one. What is the other one? 4 imaginary roots are possible if under one situation. B should be 0, D should be 0. Then 0 plus 0 you will have. Okay. So B and D should be 0. Then what you will have? 0 less than 0. So that is also not possible, yes. So we are seeing B equal to 0, D equal to 0, B not equal to 0, D not equal to 0. This possibility. If B is not equal to 0, D is not equal to 0, then what happens? In the equation, B is not 0, D is not 0. So P of X will have 2 real roots. Q of X will have 2 real roots. Again, we are in confusion. What happens if B and D are both are 0? Then P of X will become AX square plus C. Q of X will become minus AX square plus C. If suppose B and D are 0. Then what will happen? What will be X square here when you set it equal to 0? Minus C by A. What will be X square here? Minus C by minus A. This root will be imaginary, but these 2 roots will be real roots. So 2 real roots will be the correct answer. Here we are getting 2 imaginary roots, 2 real roots. We are not getting all 4 imaginary. We are not getting all 4 real roots. We are getting 2 imaginary roots, 2 real roots. This is the case you can take. So with this, we will end the class. I will put some questions in homework before ending. You can copy them and you can try them. from question number 12. Quickly, I will copy. Here. Take these around 10 questions as homework. See you in the next class.